Did you know that out there in the cosmic darkness, there are objects so dense that a single spoonful of their material would weigh more than Mount Everest? That's not science fiction. That's a neutron star. These are the leftover cores of massive stars that have exploded in a supernova. Imagine a star much, much bigger than our sun, collapsing under its own gravity until it's only about the size of a city like Manhattan. All that mass, squished into a tiny ball. The gravity on its surface is so intense that if you dropped a marshmallow from a meter high, it would hit the surface with the force of 1,000 nuclear bombs. It's an object that fundamentally challenges our everyday understanding of matter and weight. This mind-bending density is just one of the universe's countless surprises. The cosmos is a theater of the extreme, a place where the rules of our comfortable earthly existence are stretched, twisted, sometimes completely broken. We look up at the night sky and see a serene canvas of twinkling lights, a peaceful expanse. But that calm view is an illusion created by immense distance. In reality, the universe is a dynamic, violent, and utterly spectacular. It's filled with phenomena so bizarre they make our wildest stories seem tame. It is a place of endless discovery, where every new observation seems to unveil another layer of wonderful weirdness, beckoning us to ask more questions. Think about what it takes to create something like a neutron star. Let's rewind the clock, all the way back, not 100 years, not a million, but nearly 13.8 billion years. The entire universe, everything you see, everything you don't, was compressed into a single point, a point smaller than a pinhead, hotter and denser than anything we can imagine. And then, it expanded. We call this the Big Bang. Not an explosion in space, it was the expansion of space itself. In the first fraction of a second, it grew from subatomic to astronomical size, a process called inflation. The intense heat from that initial fireball is still with us today. As the universe expanded, that light stretched out into longer wavelengths, cooling down over billions of years. Today, it exists as a faint, cold glow of microwave radiation, filling all of space. It's called the cosmic microwave background, or CMB. If your eyes could see microwaves, the entire night sky would be glowing with the afterglow of creation. This is the oldest light in the universe, a baby picture of the cosmos when it was just 380,000 years old. Think of it like this. When you hear thunder, you know lightning struck moments before. The sound is the echo of the event. Stars may look like tiny, unchanging points of light, but they are colossal, dynamic nuclear furnaces. They are born inside vast, cold clouds of gas and dust known as nebulae. These are the star factories of the universe. Within these beautiful, swirling clouds, gravity slowly pulls clumps of matter together. As a clump gets denser, it gets hotter. It starts to glow. When the core becomes hot and dense enough, we're talking millions of degrees, nuclear fusion ignites. Hydrogen atoms begin fusing together to create helium, releasing a tremendous amount of energy. A star is born. This energy pushes outward, balancing the inward pull of gravity, and allowing the star to shine steadily for billions of years. Our own sun is a middle-aged star, about halfway through its 10 billion-year life. But stars, like people, come in all shapes and sizes, and their lifespans vary dramatically. The biggest, most massive stars are like rock stars. They live fast and die young. A star like our sun will eventually swell into a red giant, before shedding its outer layers to form a beautiful, glowing shell called a planetary nebula. But for the massive stars, the end is far more spectacular. The explosion is so powerful it creates and scatters heavy elements like gold. Every heavy element in your body was created inside a star that lived and died long before our sun was born. We are quite literally made of stardust. Isn't it awe-inspiring to think that the universe is constantly recycling itself, with the ashes of dead stars providing the building blocks for new life? Now let's talk about the universe's ultimate monsters, black holes. These are objects where gravity has become so overwhelmingly powerful that nothing, not even light, can escape. To understand them, think about escape velocity, the speed you need to escape a planet's gravity. For Earth, it's about 25,000 miles per hour. For a black hole, the escape velocity is greater than the speed of light. Since nothing in the universe can travel faster than light, once you cross a black hole's boundary, called the event horizon, there is no turning back. You are destined for the center, a point of infinite density called the singularity. Black holes are formed when the most massive stars, those more than 20 times the mass of our sun, collapse at the end of their lives. The star's core implodes under its own gravity, And if it's massive enough, no known force can stop the collapse. It just keeps crushing itself down until it becomes a black hole. But there's another, even more terrifying kind of black hole. At the center of most large galaxies, including our own Milky Way, lurks a supermassive black hole. These behemoths can have masses millions or even billions of times that of our Sun. The one at our galaxy's center, Sagittarius A star, weighs in at about 4 million solar masses. How do we see something that is, by definition, invisible? We can't see the black hole itself, but we can see its effects on the space and matter around it. We can watch stars orbiting a seemingly empty point in space at incredible speeds. We can also see matter, like gas and dust, that gets too close to the black hole. It gets caught in an accretion disk, a swirling, superheated vortex of material spiraling into the abyss. On a clear, dark night far from city lights, you might see a faint, milky band of light stretching across the sky. That is the Milky Way. It's not a cloud, it's our home galaxy, seen from the inside. A galaxy is a massive, gravitationally bound system of stars, stellar remnants, interstellar gas dust, dark matter. Our Milky Way is a spiral galaxy, a majestic spinning pinwheel of about 200 billion stars. Our solar system is located in one of its spiral arms, about 2/3 of the way out from the galactic center. We are on a slow, grand journey, orbiting the center of the galaxy once every 230 million years. The last time Earth was in this position, dinosaurs were just beginning to roam the planet. But our galaxy is not alone. It's part of a small cluster of galaxies called the Local Group. This group includes our nearest large neighbor, the Andromeda Galaxy, which is about 2.5 million light-years away. A light-year is the distance light travels in a year, which is nearly 6 trillion miles. So when you look at Andromeda, even with a telescope, the light you are seeing began its journey 2.5 million years ago. You are literally looking into the past. We've talked about stars, galaxies, black holes, but all of that, everything we can see, touch, detect with our instruments, makes up less than 5% of the universe. So what is the other 95%? This is one of the biggest mysteries in all of science. About 27% of the universe is thought to be something called dark matter. We call it dark because it doesn't emit, absorb, reflect any light. It's completely invisible to us. We only know it's there because of its gravitational effects. Without it, galaxies would fly apart. There simply isn't enough visible matter to hold them together. Think of a spinning merry-go-round. The kids on the outer edge have to hold on tighter to keep from being flung off. In the same way, stars on the outer edges of galaxies are moving much faster than they should be, based on the amount of visible matter we can see. There must be some extra unseen mass providing the gravitational glue that holds them in their orbits. As if one invisible component weren't enough, the remaining 68% of the universe is even more bizarre. It's a mysterious force called dark energy. In the late 1990s, astronomers were trying to measure how much the expansion of the universe was slowing down due to gravity. To their complete astonishment, they found the exact opposite. The expansion of the universe is not slowing down, it's speeding up. Some unknown energy is pushing everything apart, acting as a sort of cosmic anti-gravity. For thousands of years, we knew of only the planets in our own solar system. We wondered if other stars had planets of their own, but we had no way to know for sure. That all changed in 1995 with the discovery of the first planet orbiting a sun-like star outside our solar system. We call these worlds exoplanets. Since then, thanks to powerful instruments like the Kepler Space Telescope and the James Webb Space Telescope, we have confirmed the existence of over 5,000 exoplanets, and that number is growing every week. We've gone from knowing of just one planetary system to knowing of thousands. The universe, it turns out, is teeming with worlds. How do you find a planet trillions of miles away, orbiting a star that is 1 billion times brighter? One of the most successful methods is the transit method. Astronomers monitor a star's brightness over time. If a planet passes in front of its star from our point of view, it will block a tiny fraction of the starlight, causing a minuscule temporary dip in the star's brightness. It's like detecting a gnat flying in front of a searchlight from hundreds of miles away. The variety of exoplanets we've discovered is astounding, far beyond what we imagine from our own solar system. We've found hot Jupiters, gas giants orbiting so close to their stars that their years last only a few Earth days and their atmospheres are scorching hot. We've found super-Earths, rocky planets larger than Earth but smaller than Neptune. The most exciting discoveries are the Earth-sized planets found in the habitable zone of their star. Based on the data we have, astronomers estimate that there could be tens of billions of potentially habitable Earth-sized planets in our Milky Way galaxy alone. We began our cosmic journey with a spoonful of neutron star, a substance so dense it defies belief. We traveled back to the dawn of time and saw the afterglow of the Big Bang. We flew through stellar nurseries where stars are born and witnessed their explosive deaths that seed the cosmos with the elements of life. We stared into the abyss of black holes, explored the vast cosmic web of galaxies, and contemplated the invisible mysteries of dark matter and dark energy. We've discovered thousands of new worlds and pondered the profound question of whether we are alone in this immense universe. Through all of this, one truth becomes clear. The universe is not something separate from us. We are not just living in the universe is living in us. The carbon in our cells, the nitrogen in our DNA, the iron in our blood, all were forged in the hearts of collapsing stars. The water in our oceans was likely delivered by comets, by asteroids, ancient relics from the formation of the solar system. We are a direct product of cosmic evolution, a way for the universe to know itself. Our curiosity, our drive to explore and understand is the universe's own curiosity made manifest. The cosmos awaits.